Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic with a lovely halo in the background. In this video, I'm going to give you two of the easy rules for the quantifiers. These are the quantifier interchange rules. Now, you might remember from a couple videos back when we were talking about semantics, and I showed you that there is a semantic equivalence between not for all x not phi and exists x phi. So if it's not the case that everything is not something, then there is at least one thing that is that thing. And you can also do from the existential to the universal. If it's not the case that there is something that is not phi, well, then everything has to be phi. So the quantifier interchange rules represent this formally, except in a slightly different fashion. What we're going to do is we're just going to go from not for all x to exists x not, and from not exists x to for all x not. So there's only going to be moving of one negation. You can always reconstruct the version that we proved, going from not quantifier not to the opposite quantifier, simply because we have the double negation rules that we had from propositional proof theory. So remember, all of our rules, both the basic ones and the derived ones, we still have access to. So the version that we'll give for the quantifier interchange rules is just a simpler version that allows us to present things in a slightly more elegant fashion. So, definition: quantifier interchange, or the abbreviation that we will use, is QI. Maybe not quite interesting, but certainly quite useful. So we've got two versions of the rule, one for each of the quantifiers. So if on line I of our proof we have not for all x phi, then on line n, where n occurs later in our proof than I, we can write down exists x not phi with annotation QI line I. Other version: if on line I of our proof we have not exists x phi, then on line n, again, where n comes after I, we can write down for all x not phi with annotation QI I. So let's just briefly write down kind of the schematic version of this. So you've got, the proof, it's got some sorts of assumptions, and then here on line I, we have not for all x phi with some annotation. We don't necessarily know what. Then later on at another line n, we can write down exists x not phi, QI citing line I. And then for the other one, it's similar. We might have some premises up here. We've got some other things down here. At some line I, we have not exists x phi, some sort of annotation, we don't know what. Then on line n, we can swap this to for all x not phi, quantifier interchange line I. So what we are doing in both of these rules is we are moving the negation from one side of the quantifier to the other, and we are changing the type of the quantifier. So the reason why this captures this equivalence that we talked about when we were doing semantics, and also the one involving the other combination, is because if you had some line of a proof that has not for all x not phi, well, we can apply quantifier interchange to move this negation over, change the quantifier type. So we get exists x not, and then we just take this part of the formula down. We've got not phi, so that's QI line 1. Well, double negation says you can take two negations out at any place. So we get exists x phi like that. So double negation line 2. So that's how we can reconstruct this equivalence that we talked about on the semantic side of things, even though the way we've defined the rule, we just take our negation and we move it, we move it inside and we change the type of quantifier. So as I said, nice and easy, very, very useful, quite useful. We could maybe call it QU instead. But there you have it. We'll use this in some future examples. And the next set of proof rules that we look at for the quantifiers are also going to be similarly easy. So we'll probably get, again, 2 of them or 2 flavors in one video, just as we did now. So I look forward to seeing you in a bit. Cheers.